Hey, Mr. Mass here. Talking about spheres today, especially the volume of spheres, but there's all kinds of fun things that we can do with spheres. We can spin it on a finger, we can juggle. These are the kinds of things that you get good at in quarantine. So we got a lot of different spheres here, and unlike a lot of things, they say a lot of things come in a lot of different shapes and sizes. Spheres are a little bit different. They come in one shape and a whole bunch of different sizes. So there's really only one thing we have to worry about with spheres. Well, a couple things you got to worry about. But with spheres, as you can see, they're all the same shape, just different sizes. And the only thing that determines their measurement is the radius, how far it is from the very center of the sphere out to the edge. This is the formula for the volume of sphere. So continuing our lessons on formulas, which are just algebraic expressions that we're substituting values in. The only thing that we really have to substitute in for this formula is r, the radius. Just like a circle, the radius goes from the center of the circle to the edge. Well, the sphere is literally a three-dimensional circle. So the radius goes from the center of the sphere out to the edge of the sphere. And we don't, pi, yes, it's a variable, but we know what pi represents. Pi is about 3.14. You can go with more accurate approximations if you want to. But the only variable that we really have to substitute in for this formula is the radius. And that's why I said spheres, they don't come in all different shapes and sizes. They only come in different sizes. They're all the same shape. Whereas opposed to cylinders and cones, if you remember their formulas, yes, they were circular for their bases, but they also had the height, which helped determine their size and their shape, where the sphere only has a radius. So let's take a look at a couple examples of how we're going to use the volume of spheres. We'll do some straightforward examples, just finding the volume, and then we'll use that in some word problems. Here is a pretty straightforward problem with a sphere, and I left the formula up there as a reference. But for the sphere, as we mentioned, and we'll mention it time and time again, the only measurement that we have to know is the radius. So when we look here, it tells us right here, the radius is 4.4 meters. So that is the only thing that we need to know about the sphere in order to calculate its volume. So we look at the formula, 4/3, and it says let's go ahead and substitute 3.14 in for pi. And then we're going to put 4.4 in for the radius. Now, we still need to follow order of operations. Going way back to evaluating algebraic expressions, we substitute values in for the variables and then follow order of operations, and exponents is the first thing that we have to do. Now, before we go any farther, I want to point out something in this question. It says round your answer to the nearest tenth, but it also says do not round any intermediate computations. So intermediate, if you ever heard of that word, intermediate kind of means in the middle. All right, so the things in the middle, not at the end, not at the beginning, so the computations in the middle. All right, so we were able to round pi to 3.14, but when we find 4.4 to the third power and multiply that by 3.14 and multiply that by 4/3, they don't want us to round any of those until we get to the very end computation. So let's go ahead and get started. So 4.4 to the third power. All right, so I'm going to come down here, 4/3 times 3.14. 4.4 to the third power is 85.184. And this is what they're talking about. Don't round 85.184. Leave that 85.184. And now it's all multiplication. So we can take 4/3 times 3.14 times 85.184, and that is going to get us 356.6370133. So that's the final computation. This is where we're going to round it. All right, so it says to the nearest tenth, so we want one decimal, or one digit after the decimal. The 3 tells us to keep it as 6 because it's less than 5. So we have 356.6 cubic meters. This is still volume. It sounds kind of weird to talk about how many cubes you can fit into a sphere, but that's exactly what we're doing. So this is cubic meters. This problem looks a little similar, but it is actually different because, and we're going to mention it again, the only thing we need is the radius. However, they're telling us the diameter. And just like the diameter of a circle that goes all the way across the circle, the diameter of a sphere goes all the way across. So we have to cut that in half first. So the radius, we need 16.2 divided in half. So that gives us 8.1 for the radius. So that's what we need to substitute in for r. Same idea. We are not going to round any intermediate computations. So when we take 8.1 to the third power, we get 531.441. All right, we're not rounding that to the nearest tenth. We're keeping that 0.441 for now. Another thing that I want to mention, if you don't have a calculator capable of doing fractions, you don't need to multiply by 4/3. What you can do instead is multiply by 4 and divide by 3. So what your formula could kind of look like instead is multiplying by 4 and then divide the whole thing by 3. So we can go ahead and kind of change up this formula as well. So instead of 4/3 times pi r cubed, we can go ahead and say, oh, this is 4 pi r cubed, and then divide it by 3. So if you don't have fractions on your calculator, not a big deal. When things are in the numerator, you multiply. Things are in the denominator, you divide. So that's what we can do here. So just kind of doing it that way instead, I'm going to multiply everything in the numerator. So 4 times 3.14 times 531.441. That gives me 6,674.89896. And then when I divide all of that by 3, I get 2,224.96632. And rounding to the nearest tenth, so we want one digit after the decimal. This time, the 6 tells us, let's round up. So we're going to change this 9 to a 0, and that's going to change the 4 to a 5. Now, typically, when you have a 0 after a decimal, you drop it. But because it says to the nearest tenth, we actually have to leave it at 2,225.0. Otherwise, you're not sure if it is 0.1, 0.2, 0.3, 0.4, because all of those would technically round down to 2,225. So to stay accurate, we're going to leave that as 2,225.0 because I want the tenth. And I need to go back and check my units. We're talking about cubic centimeters here. We're going to get into some word problems now, and there are really two basic type of word problems we're going to see. One that use division and one that use multiplication. So I have little tips and hints here. Remember, the act of division is actually splitting things up evenly, whether you're splitting them into equal groups, or in this case, you're making a lot of spheres that are the same size, so splitting it up into a bunch of spheres that are all the same, but division is splitting evenly. And then the other end of that, multiplication, if you're duplicating, so it's the same thing over and over and over again. So if the situation calls for that, you would use multiplication. But in this case, you're going to see that this is a division problem. So Frank's company makes solid balls out of scrap metal for various industrial uses. His current task is to make a batch of aluminum balls with a radius of 4.5 inches, and he has a total of 76,302 cubic inches of aluminum. So how many balls can he make? So the idea here is we're taking this total amount of aluminum and we are splitting it evenly among the solid aluminum balls that Frank's company is making. So we have to find what is the volume of each individual sphere, and then divide that 76,302 by that volume. So we're going to obviously use our sphere volume formula. And as usual, we need to put the radius in for r. So we have 4/3. It says use 3.14 for pi times 4.5 to the third power. And it says do not round our answer. So we're going to keep everything as is. Remember to do our exponent first. So 4.5 to the third power is 91.125. So 4/3 times 3.14 times 91.125. And remember, we have options. If you have a calculator that can do fractions, go ahead and do fractions. If not, you can do 4 times 3.14 times 91.125 and divide it by 3. Either way, what we're going to get for our volume is 381.51. So that is the volume of each individual ball. So to figure out how many balls we can make, we need to take 76,302 and divide it by 381.51. And once again, it says don't round your answer. And there's probably a reason that they didn't want us to round this, because it turns out to be 200 exactly here. So they can make 200 spheres, all of the same size, all with a radius of 4.5 inches. So they can use those for, like it says, a variety of industrial uses. Usually when they have spheres of an item, it is to melt them down so they can pour them into molds. They use spheres a lot for this because spheres have a very large surface area because of their shape, which makes them easier to melt. The more surface area something has, the quicker it is to heat it up, and in this case, probably melt it. So we have one last word problem here before you can get to work on your own assignments here. We have a manufacturer that makes decorative globes out of silver in the shape of a solid sphere. And it says, suppose each sphere has a radius of 1.5 centimeters, and then if silver is produced at $6 per cubic centimeter, how much will the silver cost to make one sphere? So this is a situation where we're going to be using multiplication, because this is $6 for 1 cubic centimeter. So however many cubic centimeters, we're going to have 6 and 6 and 6 and 6. So we're duplicating that $6 for cubic centimeter over and over and over again, which is why it's a multiplication problem. But before we get to that multiplication, we need to go ahead and find the volume of each individual sphere. We've done this numerous times, so it should be a pretty quick process for us now. So 4 times 3.14 times 1.5 to the third power, and then divide all of that by 3. We end up with 14.13 cubic centimeters. So one sphere has 14.13 cubic centimeters. Remember, we're not rounding our answer here. All right, and then we're going to take this and multiply it by 6. So we multiply that by 6. We end up with $84.78 to make one silver sphere here for this company. One last thing I want to talk about real quick is the units here. We started with 14.13 cubic centimeters, and we talked about why these are cubic centimeters, but then we multiplied this by $6, and if you remember, it said $6 per cubic centimeter. So what that really means is $6 over 1 cubic centimeters, and this is how the units turn from cubic centimeters into dollars. What you notice is we have cubic centimeters in the numerator and in the denominator, and anytime you have factors in the numerator and the denominator, they cancel each other out, which is why the only unit we were left with were dollars. So after I finished that problem, I thought, hey, here's a quick thing that I want to go over to make sure that you understand why the unit is actually dollars for this problem. Your assignment for the later part of this week is on ALEKS again, called Volume of Spheres. It's another 10-question, 10-point assignment. Don't forget to jump in my Zoom room if you need help during your class time or during office hours. Also, a little change that we started this week. The assignments no longer automatically pop up. There was an issue where if you got stuck in an assignment or you didn't know how to do an assignment, but you wanted to move on, you couldn't with the old settings. So I changed the settings. So now to find your assignments, all you have to do is click on the 3 bars, kind of the menu for ALEKS, and go to assignments. And this assignment and all your past assignments are there. So if you need to catch up on work, you can do that as well.